The next component to add to the scene is the active grid. But before doing that, I wanted to give an overview of what the active grid is and go a little bit into detail about some of the happenings of the dynamic loading kit under the hood, which I hope will aid you in understanding some of the inspector settings of the active grid, which we'll go over in the next video. So we've already established that the world grid is made up of cells, and hopefully it was clear in the last video that the world is also made up of cells. The difference being that the cells on the world have a position in the scene and can be either in an activated or deactivated state. By default, the cells on the world are in a deactivated state, which means that the objects associated with those cells are not loaded into the scene. A cell can become activated when it has at least one user. A user is simply an entity which needs a cell and the object associated with that cell to be activated. So every frame the world sits and waits for user requests to come in. If an entity sends in a request for a cell that is deactivated, the object associated with that cell is loaded into the scene and activated. So for example, this 2-2 here, cell, may be in a deactivated state at first, and then a user request comes in, which puts it into an activated state, and the object associated with that cell is loaded into the scene and activated. The number of users a cell has is tracked, so when a cell that is already activated gets another user request, it simply adds that user request to its user count and doesn't load a new object. So for instance, if this 2-2 cell, which is already activated, gets another user request, its user count will go to 2 and a new object will not be loaded into the scene. Now, when an entity no longer cares about whether a cell is activated, it sends a user remove notification to the world for that cell, and the user count for the cell is reduced by 1. So this user here, this cell here, has a user count of 2 right now. A user remove notification is sent in. It's changed to 1, and because it still has a user, the object is not loaded. Now, if another user remove notification is sent in, and that user count goes to 0, now that cell becomes deactivated and the object associated with that cell is deactivated from the scene. So where does the active grid enter the picture? The active grid is the main entity in the dynamic loading kit responsible for sending user requests to the world. It's important to note that the world is not aware of the active grid's existence. This means that you can create your own custom components which are responsible for sending in user requests, and the kit would be able to function just fine. More than likely you will be using the active grid, however. The active grid is simply a collection of cells which are active in the scene. Those cells correspond to the cells on whatever world the active grid is synced to. So it might look like this. And it's not really that apparent, but hopefully you can see. So if we imagine these green cells here now to be the active cells, each of these active cells would directly correspond to a user request on the world that this active grid is synced to. Now it's important to note that the active grid can only be synced to a single world at a time. Now this active grid can shift in any of the 4 cardinal directions, and if you're using a 3D world, it can shift up and down as well. So if this active grid shifts, for instance, to the right, then these cells over here become activated. Which directly corresponds to new user requests being sent to the world. On the other hand, when this active grid shifts to the right, these cells on the left-hand side become deactivated. So user remove notifications for these cells are sent to the world, and if the user count for these cells on the world reaches 0 after these user remove notifications are processed, then the objects associated with these cells are deactivated from the scene. And of course, this grid can shift down or to the left or up. You can shift the active grid manually via function calls. However, more than likely you're going to be using dynamic shifting, which means that this grid is going to shift automatically in response to the player's location in the world. And to understand that, we need to dissect the makeup of the active grid. Here you can see I've indicated that it's just a 9x9 group of cells, or 3x3 group of cells. In actuality, there are two parts to the active grid. There is the inner area and the outer area. The inner area represents an area that the user can run around without forcing a dynamic shift of the active grid. So as long as the player stays within this area, no shift occurs with the active grid. As soon as he crosses one of these boundaries, for instance, let's say he crosses the right boundary, then a east shift or a right shift occurs. Now I've indicated again here that this is a 3x3 grid, but there's no requirement that your grid be 3x3. You can control both the area of the inner grid and the area of the outer area. So for instance, you could have a 2x2 inner area, and this would be made up of a total of 4 objects or terrains, 4 cells, and you could have a outer area of a width of 1 or a width of 2. Now of course, increasing the size of these different areas increases the number of objects that will be loaded in the scene at any given time. So you'll need to experiment to figure out what the best value is. And that concludes this video, giving an overview of the dynamic loading kit and the active grid. In the next video, we'll be covering configuring the active grid.